Welcome to the second chapter of Module 1. In this chapter, you will explore the problem statement and its role in the development of a logic model. The first component of the logic model is the problem statement, outlined in gold dashes here. Whether you work forward or backward in developing the other components of the logic model, you should start by writing a problem statement to clearly define what you want to address. The problem statement describes the problem that the program is designed to address. Without a clear vision of the problem, creating a clear and comprehensive logic model is very difficult. You have to know what you are trying to address, why it is a problem, and what the context of the problem is before you can clearly explain the program. The resource, Definitions of Logic Model Components, available on the Resources page of the website, provides a more complete definition of the problem statement. You can write a problem statement by answering a few questions. First, what is the problem that creates the need for the program? Next, why is it a problem? Why do you care about this problem? What negative outcomes have resulted or will result if the problem is not addressed? Next, what is known about the problem? Consider what data you already have, what work you have already done, or what research helps to explain why this is a problem. Or what research helps to explain why this is a problem. Finally, consider the stakeholders in the problem. For whom does the problem exist? Or, whom does the program seek to benefit? For example, does the problem affect students, teachers, or families? Also, who has a stake in the problem, or who has a voice in what happens? For example, if the problem is impacting students, who should be at the table to discuss the solution? Stakeholder input and views are critical to understanding the context in which a problem exists. Introduced in the last chapter, AMP is a fictitious after-school middle grades math program used as an example throughout the toolkit. The completed logic model for this program, titled AMP Logic Model, is located on the Resources page of the website. In the AMP example, the problem is that middle school students have not been completing their math homework, which may be connected to low math achievement on state assessments. The community has also complained that unsupervised students are getting into trouble after school. Incidents involving middle school students are up 17% over the previous 3 years. The research suggests that poor math performance in middle school is associated with low graduation rates. Additionally, unsupervised after-school time can contribute to more community issues, such as vandalism. The problems that the community has been experiencing could be related to unsupervised after-school time for middle school students. School data indicate that middle school students complete their math homework less than 40% of the time, and state data show that only 25% of them score proficient or advanced on state math assessments. The entire community has a stake in this issue, including school staff, students, parents, community service personnel, property owners, and businesses. Here is the example problem statement. Students at the middle school have low homework completion rates, lower than 40%, and low performance on state math assessments, only 25% proficient or advanced. In addition, the community around the middle school is experiencing issues with unsupervised students after school. Incidents involving middle school students are up 17% over the last 3 years. Stakeholders, including school staff, students, parents, community service personnel, property owners, and businesses, are concerned about the low performance and unsupervised after-school time. Research has indicated that low math performance in middle school is correlated with low graduation rates. and that unsupervised after-school time is related to an increase in community issues. The school district has recently received a federal grant and would like to use these funds to address the problem. Representatives from all stakeholder groups involved in AMP answered the questions posed earlier in this chapter to develop this problem statement. Collaborating with stakeholders to draft a problem statement like this one will ensure that everyone has a shared understanding of the problem. Here is the AMP logic model again, with the problem statement at the top in the gold box. You will reference the problem statement as you draft the other components of the logic model in chapters 3 and 4. The problem statement helps logic model developers define a problem and situate it within the local context. Here are a couple of key points to keep in mind when you write a problem statement. The problem statement should focus on defining the problem, rather than making an argument for a particular solution. Focus on what the problem is and what it looks like in the local context, and save the solution for the rest of the logic model. Use data to help define the problem. These data can come from other plans you have developed, such as improvement plans. You may not have to collect data to define the problem. You likely have existing data that can help you define the problem. Stakeholders may also be able to help you define the problem. Keep the problem statement brief. It exists to help you ground conversation about the solution to the problem. It is not intended to be a comprehensive examination of the issue. You have now completed Chapter 2. In Chapter 3, you will examine the resources, activities, and outputs of the logic model. In doing so, you will be able to answer the question, what is the program?